Now we've talked about the different layers of the OSI model and encapsulation, de-encapsulation. Let's go ahead and look at how all this works together. In order to show how all this works together, I have created a series of diagrams. In this first diagram, we see how we start out with data coming from the operating system, or more accurately, coming from applications running on the operating system, and we see how each layer of the OSI model adds its own unique header. Now, each one of these headers that are added to each layer of the OSI model give information to the computer on the other end about the data that is being transmitted. The application layer header, for example, tells the computer on the other end what applications or services running on the operating system are being used for this data. The presentation header contains information about encryption, compression, translation, anything like that that the computer on the other end needs to know in order to identify and use the data that's being transmitted. The session layer presents information needed by the session layer on the receiving end to set up the session between the two processes that the data applies to. The transport layer contains information about the specific protocol or process needed by the session layer to set up the session with. The network header provides information about the overall final destination of the data that's being transmitted. The data link layer provides the address of the next node that the data needs to pass on to in order to reach its ultimate destination. It also includes a tailer that contains some error correction information. All this information is then converted into ones and zeros, or encoded into ones and zeros, and put on the media being used to transmit the data. And that's what this particular graphic is showing us. Now, the way the computer handles this, or the way the datagrams are handled by the computer, is shown in this diagram. Basically, you start out with the basic data, and as each layer of the OSI model adds its own header or tailer in the case of data link layer, then whatever was in the datagram before the new header was added becomes data contained in the overall datagram. The result is that as the data moves through or down the OSI model, it becomes larger and larger and larger. This is illustrated by the fact that data starts out as yellow, and as it moves down the OSI layers, the yellow portion becomes larger and larger and larger because it is containing the headers of the layer above it. This data section becoming larger and larger and larger is what is called overhead. And so the more information contained in each one of the headers of the OSI model, the larger the overall data portion of the datagram becomes. So one of the goals of networking is to keep the headers as small as possible so that we can minimize the amount of data or the overhead that the network has to handle in order to process each one of the datagrams that are transmitted. Now, this final diagram illustrates how this all works together. We start on the sending operating system, or the sending computer, and we start out with our data. Each layer adds its own header, or in the case of data link layer, header and tailer, as discussed previously, until we get all the way down to the physical layer where the whole thing is converted into ones and zeros, or encoded into ones and zeros, and then sent along the media that's being used for communications. Once it ultimately reaches its destination, the NIC on the receiving computer then intercepts the datagram and starts passing it up through the OSI model. Now, as the data passes up through the OSI model, instead of adding a header, it removes a header. And as it removes a header, removing that header tells the receiving computer what to do next with the data that it has received. For example, once it gets up to the transport layer, it removes the header and examines it to find out what protocol or process the next layer up needs to apply this datagram to. Which session does it belong to, in other words? Then the session layer peels off its header and determines exactly what needs to be done in that session with the datagram it received. Then it passes up to the presentation layer. The presentation layer then peels off the presentation header, and that tells the presentation layer what needs to be decompressed, what needs to be de-encrypted, what needs to be translated, that sort of thing, and then passes that up to the application layer. The application layer then peels off its header, and it tells the application layer exactly which program in the computer this particular piece of data needs to be sent to, and what that program needs to do to the data that's passed up to that program. And so this is how the layers of the OSI model work together. Each layer provides a header that provides information for the same layer on the other end. And as the receiving computer receives the datagram and passes it up through the OSI model from the lowest to the highest, it then peels off each header, letting it know what needs to be done at that destination or receiving computer.